Hello, good afternoon. Okay, let me check the sound. Let me know if you can hear. Okay, so I think it's time. Let's get started. Let me. Okay, alright, how's this? Hey, hello, this is Junichiro Horikawa, and this is the weekly live stream tutorial live stream for Houdini, which is called as Houdini Algorithmic Live, and this is 123rd episode. The topic for today is to implement a weighted shortest path growth. Specifically, I'm going to show a growing path or growing branch inside a text, something like this, as an animation. So that's what I'm gonna do today, and it's in 3D, so you can have some perspective views like this in the end. Okay. The setup is rather simple, I think, yes, but you do need to use a bit of Vex coding, so kind of why I'm using Vex as a message. Okay, so let's do this from scratch. Hopefully it'll be interesting for you. Right, so I'm gonna move this to the up, and let's start from scratch. So the main idea is to use a shortest path, as the title says, so it's pretty straightforward. So before getting into the network or the branches, let's start by creating a boundary. In this case, a text object. So I'm gonna start by creating a geometry node, create a font, and use any message you want to create a branch animation or shortest path animation. So I'm gonna also create a null node, which could have a parameters which can be controlled globally later. So I'm gonna name this controller, like in every other video that I do. Okay, and I'm going to make a parameter call for a string message where I can choose what word to type. So I'm just gonna call this word. Let's just try to do the exact same sample that I made as a test. Then later we're gonna be changing the text, or probably the font as well, those font, to see the differences. Especially the alphabetical characters are pretty simple, but if you try to use like 2-byte characters like Japanese or Chinese or Korean, it's gonna be you're gonna have tons of geometries in one character, so that might going to change the behavior. So let's see how it affects. But let's start by real simple message or letters. I'm gonna copy this, paste it here, so we can link the message like this. Hello everybody. And first thing I will do is to create an attribute for each letters, which letter belongs to which index. So I'm going to check this add text attribute, which will create a primitive attribute like text index and text symbols. And this text index is pretty important. It shows which letter belongs to which index. So 0 starts from the left hand side, so V is 0, E is 1 and x is 2. Okay. All right. Now I'm also going to use a connectivity node to define which object belongs to which island and make it as a primitive. Now that I thought, maybe it's better I use a bit more complex letters as a test so that it can also be used for simple letters. So let me see, maybe something like this one, or so I has 2 island like this, J also has something like that, and yeah, we could test with these, I guess. Other than that, something like semicolon. These are all vertically long. Maybe it's not that. Let's just add some letters in between. Okay, so let's test with these. See how it goes. All right. Then we have, yeah, so 0 index, text index has 2 primitives, meaning this one, and so on. All right, so that's good. And the primitive connectivity will give you each primitive a unique ID like this as a class, so that's also useful later. Okay, and we'll see why these are important later. Okay, so now if we look back to the animation that we're going to create today, if we look at the text or curve, we can see that there is a path going from the start point to some goal point like this for each letters. So what we need to do first is to create set a starting point for each letters. So in this case, if in case of this letter V, the starting point is somewhere around here, and for the letter E, the starting point is somewhere around here, and the X is somewhere around here. So for each letters, I would like to set the starting point for the branch, then also set the end point for the branch. In the case of V, it's being spread out everywhere inside the characters. Same for E and X. So, and we can also see that there is some flow going from the point to fill the whole letters, like I don't know, like how the IV growth, or how the fluid flows inside a boundary. So we're gonna create this guide how it should flow, how the branch should grow inside a boundary. So in order to do that, we need to have some kind of a bone structure for each letters in order to create the guide. So that's what I'm gonna do next. So for each letters, I'm going to pick the starting point as well as the direction from the starting point to the other places, how the growing path or growing branches should direct it or go. And that's kind of why I have titled this live stream weighted shortest path growth. Okay. So let's do this, and I am going to do that by using a side effects labs component or side effects labs node called straight skeleton. lab straight skeleton 2D, which will give you a bone structure of 2D polygon. In this case, this will create a bone structure for each island or primitive. Let's see how it goes. So create something like this. You can do the pretty similar stuff like these by using a Voronoi, but this is a simpler way to achieve simpler way to get the bone structure of the polygon, so I'm just gonna use this one. And since I don't want to have these crosses on the corners, so we'll try to modify the parameter a little bit, like increasing the threshold a little bit so that I could have a straight line like this. Okay, so that looks good. Now I'm going to clean this up a little bit. First, I'm going to connect clean, check if number changes. Nothing changes, so that's good. I'm gonna try to use the fuse as well, just in case. Might not be necessary, but yeah, wasn't necessary. Now, first thing I would like to do here is to pick one point which is going to be the starting point for the flow or the growth. So how I should do that? In my case, I would like to make an animation from left to right to grow. So I would like to try to pick the point from each letters which is on the far left side, and it should also be the corner of the curve, or the end of the curve, end point of the curve of each curve. So I guess there are many ways to do that, but one of the way I could think of is to first say sort the primitive by x, so that the primitive will be sorted from left to right. And then I'm going to use another sort and sort it by a class attribute. It might not be necessary, but let's try to have it. If I have two classes, wait a minute, I might not need this, so I'm just gonna ignore this a little while. And let's try to pick one primitive from each letters, meaning there are multiple primitives which belongs to same letters, which you can check from checking this text index. So I'm gonna try to get one of the primitive from each letters. Now before doing that, let me check how these texts are being made. So this one is split it into several pieces like X, and this one is just one curve, this was just one curve and one curve. First, let me try if I can connect all these together by using polypath, just in case I have longer connections, like for example for X. Maybe not, didn't really help, so maybe I don't really need it. Okay, so let's try to just pick one of the primitive from each letters. So I'm gonna use a attribute wrangle for that. Alright, and then let's see how I should go. So Well, now that I think of, I shouldn't just get the single primitive from each text index, but I should get each primitive from each class, because you also need to get this one in order to fill this primitive alongside with this one. So now that I think of, you have to look into the class. You have to get one of the primitive from each class. Okay, so that said, let's do that. And I'm going to use a detail angle to try to do that. Okay, now how should I do that? Okay, first let's see. Well, I guess the easiest way is just to use for each connected piece, or for each named piece, look into the class, and for each class object just get the most just get the object which is placed on the most left hand side, which has been sorted from left to right with this one, so you can just get the first object from each class. So I'll just use the delete node, get the first one and exit, and this should be the one that's placed on the left hand side. Okay. Now the next thing I would like to do from here is to pick the endpoint from each primitive. In this case, the point that's on the left side. In this case, that could be either bottom or top. This could be this one. This could be this one. But I might want to make it from left bottom to top right to animate. But well, for example, for this one, this is on the left top, so it's a bit hard to decide. So I'm just gonna give a query which is if the point is being placed on the far left, then that will be the starting point. And that's it. So let's do that. And in order to do that, let's see what's the best way. You could first of all make sure that the point is being sorted out by vertex. Then I don't know, use something like primitive wrangle, pick the endpoint, the starting point and endpoint, and compare each two points, and if it's on if either one is on the left hand side, then just pick that one. So get the point list. The first point is at 0, the end point at the end of this list, and get those point position. Compare the x coordinate. Then if it is so, then that will be the point that I want to have as a starting point. If not, use endpoint instead. Okay, and oops, I don't need these. And in the end, just remove the current primitive. Alright, so this will give you a bunch of points, which can be a candidate for a starting point. Alright, now I want to transfer some attributes to these points, which could be derived from the original primitive, something like a class information or text index information. Yeah, like that. So let's transfer the class and text index to each starting point. Okay. So I'll do that by creating a variable like point outside the conditions. Fill in the variable, then transfer the attribute like class to the newly created point from the primitive, as well as the text index. Okay, let's check. So I've just now created the point, which is going to be used as a starting point for the growth, and I have class information and text information which used to belong to these text, which gives you an information which point belongs to which text and which island. Okay. Now that I have these, let's try to have a endpoint for the growth. Now, for the endpoint, I could just make a bunch of random points inside the boundary. In this case, from these text object, and I could also make it as a 3D geometry. So I'm gonna use a poly extrude to thicken the text. Now this could be also parameterized, I guess. So I'm gonna give another parameter to control the thickness of the text. Alright, close the backside, so it'll be closed geometry. Okay, now I also want to place this, the center of the text to be on the center axis. So I'm going to use a transform node to move this geometry back to the center. This axis to be the center. So I have moved it on to Z axis, so I'm going to just move this half size of this extruded object. So Z size Z 0.5, right? Okay. Hello. So from here I am going to create a volume using ISO offset in order to scatter points inside the object. I'm gonna make it as detailed as possible, and then use scatter node to create a bunch of points inside the geometry, which is going to be used as a goal points. Okay. Now, every point could be a goal points, or you can just pick a random number of points from here to use as a goal points. But every point is gonna be used as a path points, the path node, to calculate the shortest path. So the many points you have, more high res path you get, and also you can control the number of goals to control the final number of branches. So let's have that as a parameter as well. So first of all, control how many number of points you want to have. How do I call this? Path node. Number of path nodes. As well as some float number to set like what percentage of these points be used as a goal points. So goal ratio could be 100% or could be like 1 to 2% to have small number of path. Okay, and the ratio should be 0 to 1. Alright. Let's set the number of points to 10,000 so that I have enough points to create a bit high res path. Okay, so it's time to set the goal points from these points. Okay, so in order to do that, I'm going to use a point wrangle and use the random value probably derived from the point position is fine, and then use the threshold to see how what percentage of points be set as goal. I'm gonna set the goal group to those point met with this condition. Okay. Okay. Now I already have the ratio parameters, so let's make this to 0.5 so that 50% of the point will be used as a goal point. Then copy that parameter here. Okay. Now I also want to set each point, each scatter point, to have corresponding class number and index number, just as the starting point numbers that I did here. So I need to somehow transfer those information which is probably from here or here. Okay. So let's do that. Let's see, where should I get that information? If I look at these extruded object and look at the primitive attribute, so I already have class and a text index, and I want to pass these information to a point as an attribute so that I can use it later. In order to define which paths should be connected, I mean to use in which letters. Okay, so, or which island. So to do that, I want to pass a primitive attribute which exists in here to a point here. So let's see what's the best way to do that. Now I think all the points, now looks like some of the points are outside the primitive, so that might going to be a little problem. So let's also trim out those points which is outside the primitive and just get the points which is inside this geometry and attach an information which the the point, apply the information for each point, which tells you which point belongs to which primitive, which geometry, or which letters. Okay, so first thing first, let's see if the point is outside the geometry or not by connecting the 3D geometry to the second input here. And I could do that before setting the group, I guess. Or do this separately, maybe. For setting the goal, I could make it as an individual component or node like this. And I'm gonna create another point wrangle so that it will be easy to see later. To trim and transfer attribute. Okay, so first thing first, let's check if the point is inside the geometry by first of all we need to have the normal information from this primitive. So I'm gonna calculate the normal from this primitive as vertices is fine, I think. So which will give you normal information like these. Okay, now next I'm going to calculate the closest point when the point touches to the surface as a closest point. I want to get that point information on the primitive, then get the corresponding normals and point position. So to do that, I can use a function called xyz distance. XYZ distance gives you a distance, closest distance, as well as the touching primitive and touching UV, which is pretty useful in order to get all sorts of information, such as the normal attribute on touching point. So as a result, you are getting the touching primitive from the second input, which is this geometry, also the UV, so that you can define the exact position where it's being touched. And using these two values, you can use a function like primuv to get additional attribute like normal. And use it to check whether the point is outside the primitive or not. And to do that, you need to also get the touching point position. Using the same primuv, get the point position, then calculate the dot product between the normal and the normalized of position, the touching position minus current point position. Okay, so if this is positive, this means the point is inside the geometry, and if it's negative, that means the point is outside the geometry. So if the dot is negative, then that means the point is outside the geometry, so you want to remove that point. Let's see what happens. Now all the points which was outside the geometry has been deleted. Well, some of the test is being failed, probably due to the miscalculation of the normal direction, I guess. So in those cases, well, there are several ways to fail test one. One of the way is to divide the geometry so that they'll be triangulated. Didn't help much. Okay, another way is to use a point normal instead of vertices. That might help. Yeah, because the point normal gives you a kind of a interpolated normals on the corner, which gives you something like these instead of a straight normal, which is derived from the primitive, so which might give you a better result in this case. Okay, so I guess this is better. Now next, I want to give a attribute like text index and classes derived from the primitive, and you already have the primitive information, which is this one here, derived from here. So from here you can actually get the class and text index using prim function, like this. Okay, and you just need to pass these information to a current point text index and class. And let's check. So for each point you have, I think you have successfully passed the class and text index. And this number should be corresponding to the boundary object, which comes from the second input. Okay, now so far you have the goal points and the starting points right here. So now you have those two sets of points. You are ready to create a initial path using shortest path. Okay, so let's do that. So let me check. So these points also should need to have a group called start, indicating that these are the starting point. Okay. Okay, now that I have these points, let's merge these two together. Okay, so now I have combined both start and end point. What's this? New ends. Where does this come from? Not sure where this come from. Probably coming from here. Okay, I'm just gonna ignore that. So I have start and goal. Okay, now next thing I'm gonna try to do is to trim some of the points if it's too close to each other, or maybe not. Well, just gonna leave this for now. Now, first thing I need to do is to create a connection between the closest point and use that connection as a candidate for the shortest path. So let's do that. Now let's see how I should do that. Well, I am going to use the point wrangle. Name this path or network. And try to first of all figure out the distance, the shortest or the maximum distance for the path or the network. Okay, so I'm gonna call this maximum distance, and let's try with some parameters to test. Okay, I'm not sure what's the best for this numbers. Might need to specify this automatically later, but for now, let's do this manually. Now, after doing this, I am going to let's see. Okay, I want to create a connection between each point which shares the same class. So I shouldn't create a connection between different classes like these, but I should only make the connection in the same class attribute. So what I should do here is to find a closest point using near points from the same input, and using a filter which shares the same class as your own class, starting from the current point position. Then the distance, the maximum distance could be this threshold, and you could also define the maximum number for the connection. Which might not be really important, but let's see. And let's set it to 10 for now. Okay. Now, now that I look for each point, in this case, you are looking at the same input, the 0 input. So if you use a new point with zero input, the first point number from this near points function is always yourself, meaning at ptnum. So for that, you could just ignore that point to create a network, because you don't really need to create a line between yourself. So you could always start from 1, then meaning you're skipping 0, the first number, then get the near point position. Right. Now what you want to do next is to what you want to do next is create a line between those 2 points in some conditions, and the conditions that I want to create is if the current point number is less than npt. That is because there is a chance that you're creating duplicated lines if you just do the loop for every point. You're always going to have a doubling pair. So by creating a conditions like these, you can skip one of the duplicated lines, checking whether yourself is less than the neighbor points, the target points. Probably. So in the end, you can then create at prim polyline ptnum and npt, and probably you didn't really need this. Now you have a network like these, by increasing the threshold and the number of neighbors, you can control the density of the network. Now, probably you could automatically define this threshold t by checking the average distance between the points for each primitive. It might not be a good idea to just set these values by yourself, because these values will change based on the density you have for each point. So you have less number of points, then obviously you should have different threshold values for this one. So it might be a good idea to just automatically define this one instead of manually setting it up. So let's try to do that. And also I would like to create a weight to each point, how easy it is for the path to reach there, to create a flow, to create a kind of a IV-like flow or not. So let's try to do that. I'm going back to the scatter point, increase the number of points. Okay, this is too much. Let me limit the number of points to 10,000 for now, or 3,000, 30,000. Okay. Okay. So before creating the network, I'm going to see what will be the best way to define the distance. Let's see. Let me think. So what I could do for each point, I could just get the nearest point distance, then have that as an attribute for each point, then get the average or maximum or medium or something like that, and use that as a base searching distance. That might make sense, I guess. Okay, so shall we do that? Shall we do that? Let me think. Yeah, and also in terms of the weight, I could use these base bone structure of the curve to define how far is each point to this curve, or to the end point of this curve. Okay, so let's see. So from each curve, I have defined the starting point. Like, for example, if for the case of I, the starting point was, I guess, here, and for the X, the point was here, I think. So I want to calculate the distance for each point inside a curve from the starting point. So if this is 0, then this is 1, 2, 3, 4, 5, and this is the maximum distance, or this could be the maximum distance, and so on. And I'm going to use that information as the reaching distance for each point, for these points. So I want to transfer that distance information to each point here and use it as a weight value to define how easy it is to reach to that point, to the edge. So I am going to, how would I do that? So from here I am going to use the point function. Oops, point wrangle for these curve. Let's also check the number of points that I have, and I think I have enough points. Yeah, the resolution is high enough to give high res information, so that's fine. So I'm going to give a edge distance information to each point. The distance from the starting point for each primitive. Okay. Now, so in order to do that, I also need to have a starting point information. So this is the starting point information for each primitive. So I'm gonna give it as a guide. Now, it's time we write the code to find out the distance. So I'm going to use the function called find attrib val, looking for the point attribute and looking for the same class. And there's only one point for each class for the starting point. If you look at the point attribute, every point has unique class number. That is because you only have one starting point for each class. So you only get, oops, it's been deleted. You only get one point number if you search for the primitive. I mean, if you search for the class number. Like this for attrib val, point, class. So you always get the same point number if by using the same class number. And then from here you can get the point position. Then by using this you could get the corresponding point number from yourself using new point 0 position. Okay, now now that you have a point number, you could use this to calculate the edge distance, the distance from the starting point to every other points on the edge, by using a function called surface distance. And there's a mode to calculate the edge distance, so we could do that. Now the first parameter is to convert the nearest point, new point, which indicates the starting point number from yourself, which should be somewhere around here or somewhere around here, here, and so on. And you are looking at the point attribute, and the target is each point number. And as an output you get the closest point number, which is really not necessary in this case. And you have to define either surface or edge. In this case you are calculating the edge distance instead of the surface, so type edge. Now as a result you get a edge distance. Okay, so let's check. So if you look at these are the numbers, the distance on each edge, and some points are having 0, I mean -1, so maybe something is wrong. Let's check. So in order to check, the easiest way I could do is to use a color node to use the point attribute to color the distance So I'm going to make it like infrared, and so except for I, everything is being purple, meaning probably these are all -1. So maybe something is wrong here. So I might be missing something here. Let's check. So first thing first, I need to check whether I'm getting the correct point number here. Okay, C, PT, so it's all 0. Okay, something is wrong here, obviously. So let's check if I have a class attribute. Yeah, I do have a class attribute. And do I have a class attribute from here? And I realize I didn't have the class attribute for each point. I only have class attribute on each primitive. So that means I need to transfer this primitive attribute to point. The class attribute. So from primitive to point, just transfer class. Don't delete the original. And now, okay, I think the attribute has been transferred correctly. So going from 0 to some high numbers, so on. So W has longer length, so you have more distance. Alright. Now, next thing I would like to do is to let's see. Now that it's good to have the edge distance like this. Now next thing I would like to do is to transfer these information to each of the point here to use it as a weight value. Okay, so let's do that. Okay, so I'm going to use another point wrangle. And let's call this add distance weight and search for the corresponding points. Now I could just use a XYZ distance again, but you need to limit, you need to filter in which primitive you should look for. In this case, you need to look for the same class again. So in this case, I'm gonna use XYZ distance, looking for the second input, and look for the same class as your own class, using at P to find the closest point. I'll put the primitive in UV. Alright, now then you could get the edge distance from the primitive by using prim UV d prim UV. Right. So this is the closest distance, and this is the edge distance. So you have two types of distance. So maybe you could use those two as a type of weight, right? So let's have some like control to lerp between the closest distance to edge distance to see the difference, how the connection will be made. If I use the whole, if I use the edge distance as a weight, it might look different. If I use the closest distance instead of edge distance as a weight, then that might also look different. So let's give a chance to switch between those two. I'm gonna create the attribute called weight and lerp between closest distance and the edge distance based on the some threshold again. Okay, I have some errors here. No comma. Okay, so if the value is equal to 0, you are using closest distance for 100%. If it's equal to 1, then you are using edge distance for 100%. So let's see how it differs. It's gonna go from 1 now, using edge distance for 100%. Meaning using this gradient value as an information, as a weight value. Okay. So now I have those information, and now I have created those network. It's actually a time I can create a shortest path, I think. Now I think I forgot one thing to do. I wanted to replace this value with some distance value that I found out here or here. So let's also do that. Okay, so this one doesn't have information like that, so I'm gonna create another point wrangle to calculate the average distance between the points, which I should do where should I do? Well, I should do here, I guess. Okay, so just gonna use npt near points and npt near points 0 and use at p, and you only need 2 nearest points, and the first point is always yourself, so you just want to get the second point number. So the near points distance could be really high, and the maximum number of the nearest points should be 2, so that you only get 2 points. Could be higher. Now the only point number you want to get is the second one. Then you could get the nearest point position, calculate the distance between yourself and the nearest closest point, then apply that to a attribute. New distance. Let's check. So I have these numbers. So these are the nearest point distance from each point. So from here to here probably is something like 0.02 or something. Now let's calculate the average or maximum. Probably a maximum is fine. Calculate the maximum to detail. Max near distance. Check how it looks. So the maximum is 0.06. So this could be used here instead of these values, just to make your life a bit easier. Okay, so instead of getting the parameters, this one, you can just get the detail max near distance. Okay. So that you don't really need to have these anymore. You can only use the maximum number to control the number of connections. I mean, there might be a chance you wanna increase this maximum distance like by multiplier, but in those cases, it's up to you. But for myself, not gonna do that. So I'm just gonna delete these parameter. Just have this parameter as it is. Okay, let's promote that attribute, parameter, to the global parameter list. So where is it? This one. So this is max connection number, which is not that straightforward, but it's okay. Okay. What else? So I think I have enough information here. What else I need to give? Well, I probably would want to let me think. Let me see. Is there anything else I need to think about? So probably this is all I need to do in order to calculate the find shortest path node. Find shortest path, I guess. So yeah, let's try, shall we? Let me just check the previous examples that I made if I'm missing something. Well, it might be necessary for me to normalize this edge distance value, because currently the distance is linear based on the distance, like d, but I might want to make it from 0 to 1, but maybe not. I'll just test. So so after I have created the network like these, it's time you create the shortest path from starting point to each goal points. So let's see, where is the starting point? The starting point is the one that has red point, so somewhere around here and there. And let's also check the goal points as well. The goal is where the point is in green, so you have a bunch of goal points, and if you decrease the ratio, like here, you can decrease the number of goals, like that. Okay, now we want to use these 2 points to create the connection, the shortest connection. And you can use that, and we can do that by using a shortest path, find shortest path. Okay, so the start point is start group, the end point is goal group, and we want to have a network going from each start to from each start to each end. From each start to each end. Okay, and let's reset the viewport, and yeah, something has been created. Now, so the network's being created where the connection's being when you have a network, and you already have a network for each primitive, so you already have some connections like these, And next thing you want to do is to use the weight that you have set here. In this case, the name is called D. Transferred it as weight. Okay, so let's use the attribute weight to control the flow of this growth branches. So you can do that by going to the path cost, check point cost attribute and type weight. And then once you type that, I think you have noticed a bit a difference on the path. Let's see how it differs by changing the lerp value that I've created somewhere. Where was it? Where did I set the weight? Here? Okay. Okay, this was... Why did I name it max connection number? Okay, I should rename this. This was called... this is how do I call this? Net edge distance weight. And if I change this value, you can see how the network's been changing. When the value is really high, it's using the edge distance, the flow going from start point to end point, so you have kind of a linear network going from start to end, like a W shape. But if it's going to 0, then you're not using the distance, but instead you're using the distance from each point to the closest bone structure. So you create more like a frost-like shape. So that's a bit interesting to see. Okay, now it still is a bit too jaggy, so I want to make it smoother. So let's do that next. Now next, before going to make this smoother, I want to also transfer, I still want to transfer the attributes like class and text index, which this shortest path doesn't have any, so all the attribute is gone, even from the point and primitive. So I would like to transfer those information, like which path belongs to which text or class. So let's do that. I'm gonna do that by using attribute transfer. And then I am going to transfer the primitive attribute, or maybe the point attribute, the class, and the text index. Since the point is in the same position, you can just use this attribute transfer. Okay, let's check. So now I have class and text index. That's good. All right. So after this, I'm going to fuse this so that I can delete the duplicated points, make it a little bit lighter. Then next, what should I do? Let's use a resample node to add additional points to these network. I'm going to turn on resample by polygon edge so that I can keep the original point position, and uncheck maximum segment, and instead I'm going to check maximum segments so that you can define how many divisions you can get for each line. Before it looks like this, now it looks like this. This is just to make sure I have enough points to smooth the curve. Now I'm going to use a smooth node. And probably by changing these numbers you can control the smoothness of the curve. Now when you do the smoothing, you're starting to have some nice curve, smooth curve. By controlling these, you can control the hardness. If you have less number of points, less number of segments, you're getting more Haley-like network. I found out 3 is somewhere good, but it also depends on how many path nodes you have. If you have a bunch of path nodes, then you might want to make these number smaller like these, but it's pretty up to you. So probably this could be another parameter candidate. So let's give that a chance. Smoothing segments could be either from 1 to 5, maybe 5 could be the maximum. You don't really need that much. Okay, now let me decrease the number of points a little bit. Okay, so from here it's time I start creating some animation and also the scale for each point, so that I could have more like a ivy-like branch or root. Okay, and try to make some nice and growing animations out of these. Okay, so first thing first, I am going to create a scale value to create a nice looking branch out of these paths. Okay, so let's do that. And in order to do that, I'm going to think about how I should control the thickness of each branch. Okay, so probably when the same points are being used many times, then that point should have a higher scale, higher radius for the branch, I guess. So first thing I could think of in order to define the scale is check how many times the point has been used for each shortest path, and use that count value to define the scale. So let's try doing that. Okay, so to do that, we should do this before creating a smoothness, making smoothed value. So probably we could do right after the fuse. In this case, this is still coming from the original network. This one, the point hasn't been moved, and if you look at each primitive, you see some of the primitive is sharing the same point, like these, like these, like these, like these crossing branching point. And we can check at each point how many times these points being touched or used by each primitive, and yeah, use that count information to use it as a point scale. So to do that, I'm going to use a point wrangle and name this count primitive count. So how many primitives the point has is the one that I need now. So for each point, I'm going to get the connected primitive by using the point prims function, which will give you all the primitives connected to this point, specific point number. Then the number of the primitive is the count we are looking for. Okay, let's check it. Try to visualize the attribute that I have just created. Okay. So, as you can see, this point has 8 primitive. This one here has 2. This one has here 2, 1, and 1. So you can see that where it is close to the starting point has all the branches. So you have like 170 counts. And if you go to the child branches, you're getting less and less primitive numbers. Okay, so I think using these numbers as a candidate for the scale, it makes sense. Alright, so now that I have this count number, let's also get the maximum count number out of these points. Okay, so I'm going to use a attribute promote. Promote the point count attribute to detail. Get the maximum and name it max count. Okay. And I also want to get the maximum count number per class. So for each class, the maximum number should be different, like this one and this one and this one, because I want to make an animation for each class. I think I shouldn't just use the whole maximum, but have to do it for each class value. So instead of using the detail, probably I could make it promoted to the same point, but using the piece attribute called class. Then change to max count. Right. So that will give you a new max count attribute to each point per class, like that. So per class, the number is different. I think this makes more sense. Yeah. Okay. Now that I have this information, let's see how I could calculate the radius. Okay. Well, well, we could also have another maximum count just in case, promoted to detail instead of the class. See which one's better. Okay, so now let's try to convert the count value to the p scale. Okay, so I'm going to do that by using point wrangle. And get the max count. First of all, let's try to get the max count from the point. Calculate the value by dividing the current count by max count, which should give you the value in between 0 to 1. Then if you just use the linear value, then the starting point must be really too high, so you might need to create some cramps or CH ramp to control the curvature, or the curve, control the thickness curve using these count. I think the linear mapping doesn't really work well, so try to use the ramp and then finalize the P scale. Okay, so not sure what will be the best for this curve, so let's leave it as linear value for now and see how it really looks as a final result. Okay, so how should I do that? I'm going to use a polywire to create a the pipes for each primitive and see how it looks like. Now, probably right after the smoothness, and make this something like 0.01 multiplied by P scale, and make the divisions a bit smoother, like 8. Reset the viewport. Okay, so this is the initial look. Now I might need more thickness, I guess, and you could also control the curve, because as you can see, the thickness on the starting point is a bit too big. Too thick for sure. Okay, so let's try to control that. Going back to, let's give the default thickness like 0.03. This might be parameterized as well. Okay, something like this, and let's go back to the prim count. Nope, not here. P scale. Let's try to control this curve. See what's the best. Okay, make it B spline. So what if I make a curve like these? Okay, or these. So this indicates that if the x is equal to 0, that means so this is where the maximum thickness is being calculated here. So what I could do first is to lower down this a little bit, make a curve like these, make an S curve like these. Maybe not. Still a bit too much. So let me think of another way to smooth out these thickness. One of the things that I could think of here, probably the the problem here is that the difference between the starting point and the other branching point is too big, because the branch point always being counted as one. I mean, it's always been used for counting up, so we might want to ignore that value when we calculate the p-scale. So or when we are calculating the maximum count. So what we could do is let's see where we were counting the primitive count. Yeah, here. Okay, so when we were getting the maximum count, now this is the starting point count, and it's obviously really big compared to the other points. So I might want to skip the first maximum one, but just get the next one. Okay, so how can we do that? In those cases, we could skip counting the number when the group belongs to start. And do we have a start group here? No, I don't. So we also need to pass the starting group information before calculating the shortest path. So this one has the start group, so we could transfer, or can we transfer the group? Let's see. So right after I have calculated the shortest path, let's see if I can transfer the group. In this case, a point group, specifically a start group. And yeah, let's have a distance threshold. And let's check using the color node, using start. If I have yellow points on a start point position, yeah, the transferring group is successful. Okay, now you can go back to where I was counting the group and skip the start. Now this should give you the maximum count to skip the starting number, so it gives you a maximum count 55, the second largest number. Okay. And the problem is that the starting point will become 0, which will give you the 0 p-scale value here. So probably I want to transfer the second maximum value to the start. So right after this, maybe in the p-scale, or maybe just before the p-scale, I'm going to create another point wrangle for the start to try to copy the maximum count to count. And now the starting point has the second largest point count. Okay, now let's go back and see how the result looks like. Now I think it becomes a little bit better. Let me change the curve a little bit so that this will become, oops, somewhere, oop. Okay, now I guess the value is still a bit too large on the end, so the next thing I could think of to smoothen out the p-scale value is to use the attribute blur for the P scale. Okay, so let's try doing that. I'm going to use a attribute blur to control the P scale and uncheck the pin border points and increase the number of iterations, starting to give you a smoother result over the P scale and could give you a little bit better result, but you also get some unwanted effects here. So the problem here is that the endpoint is not restricted anymore, so it could go higher than 0 on the endpoint. So what I want to make sure is that at the endpoint you always want to have the value 0 for all the branches, so that you don't get thick end points like these. You always want something like these at the end. Okay, so that's what I want to have. So in order to do that, you could use a attribute here, weight attribute, to control the edge restriction. So let's do that next. So you just need to fix the end point to 0. Okay, and for all the other points, you could keep the weight to 1 so that it can be smoothened out. So with that in mind, I could use point wrangle or primitive wrangle, maybe primitive wrangle. Okay, and smooth, gonna call this smooth weight, or P scale weight, P scale blur weight. And for each primitive, I'm going to get the points, get the last point, which will be the which should be the scale equal to 0. So end point will be this point number, and then set point attrib weight and PT to 0. And all the other points should have attribute equal to 1, so I'm going to create attribute create beforehand for each point to have an attribute called W, and the default value is 1. Okay, so you have a W, and here I'm setting the endpoint to have a weight equal to 0, so that these points should not be affected by the attribute blur. Now use weight here. Now as a result, you get a nicer result. Now obviously this one looks a bit too thick, still too thick, so might need to control that. And to do that, I might need to go back to this P scale and let's see. Now this first point, let me decrease the number of. Okay, so this is not really changing the starting point P scale. maybe a little bit, but not so much. Okay. So, what else I could do? I have these curve. Let's see if the curve is good enough. Well, maybe I could do more of. I could do more to convert the count number. So let's see what else I could do. Okay, so I think. So first of all, maybe the first thing first, the maximum count still is a bit too big. So let's try multiplying this by 0.1 and see what happens. And then everything becomes really huge. Okay. Now, the problem is that the difference between the largest scale number, the largest count number, and the largest smallest count number is pretty high. So let's see. First of all, I'm going to make it as a float. Okay. Then, instead of using this kind of a simple calculation, let's see. It's okay to divide by max count, but for the count itself, I think I should limit this value a little bit. For example, get the minimum of count and a max count, I don't know, of 0.5. This will reduce the maximum count number a little bit. And by changing this value to like 0.1, the whole thickness becomes really close. If it goes 9, you have more differences, more distributions. Guess 0.5 is a good number here. Alright. Now, and you also might want to have a minimum to 1 as a value, so just to make sure that you don't get 0 on the end. I mean, it might be okay to have a 0, but just to make sure you have some thickness to render, gotta make sure you have at least 1 for a count. Then finally, I might be able to control this multiplication a little bit to control the whole thickness, and I have some problem here. Well, if I make it 1, then that's okay. What if I make this to 0, make it 0.1? Well, yeah, I still have some problem here. Let's see what's happening here. And check here. Let's check the p-scale value. Okay, so I probably want to have these values to be equal to or close to 0, but somehow I have 2 points here for some reason, or maybe multiple number of points for unknown reason. Well, I think I was just visualizing different value. Okay, let me check this again. Okay, I should only have p scale. Let's color this red. Okay, so looks like these. Okay, so these are, I want to make these endpoint to become 0, close to 0, but it's not, so might need to fix that. And let's see where I can fix that. Okay, so this is where I'm using the count, using count number. Okay, p scale. Okay, so here it is. So since the difference between the max count and the count is too small here, so that's the reason why I'm getting higher value here. So instead of using these, I think I should use, wait, what happened? I think I should use fit function instead. So I count. And probably I could copy this here, and that is in between 1 to this will be the maximum count, I guess. Is it? No. This will be the maximum count. It's hard. Well, let's see. This is the value, and I want to make it from 0 to 1. See what happens. Or maybe I could make it like this. Okay, now it becomes all 0. That's not good. If I make it 0.5, nope, still not. Okay. The I count is in between 1 to a I max count for sure. Yep. Now this will give you a linear value. Alright, but this is the problem with this is that you have higher difference between the starting point and the next point. So before using this, would like to clamp the C with the 1 and max count. Multiply by 0.5. Yeah. Then fit the C, and this should be the maximum count. Now this gives you all 0. That's not good. Okay, now this has to be a count. Okay. Well, now this is still really close to, I mean, everything is equal to 1 here, but might be okay because I'm going to smooth it out later. Now, going back to the last one. Okay, I'm seeing some weird result. Okay, let's see. So let's check the p-scale one by one, having resample. Okay, smooth it out. Okay, somehow I'm getting 1 here. So that's not good. Okay. Seems like I have multiple number of connections or branch points here. So I need to take care of that as well. Well, okay. I guess in those cases I could just give a multiplication to the count number, give a multiplication for a curve u to these max count number. So let's try to copy this one. Before doing anything, I'm going to use a kind of a resample node to calculate the curve u. Actually, I'm not going to resample, but just going to calculate the curve u to the current points, give you value from 0 to 1 to each point based on where the point is, and multiply that value to an I count so that but the minimum is always equal to 0 and so on, and the maximum is equal to multiplied by 1. So where should I do that? I could multiply the I could multiply I count by curve u, 1 minus curve u, so the end point will be 0 and starting point will be equal to 1, and then the end point will have 0 value and the max count. You can clamp with max count, and now from 0 to max count you can do something like this. Didn't work. Didn't really work. Let me see how this looks like without the CH ramp. Okay, that doesn't look correct. Okay, what if I just use curve u? Okay, and 1 minus curve u. Alright, and if I multiply this by I count, okay, still okay. Now maybe I could just use these to try out, see what happens, but might want to divide this by a max count to see. Okay, now let's see what happens. Okay, a little bit better than before, but still has some too thick branch on the starting point, so I still might need to clump it. And the place where I can clump is here and here. Okay, so let me do this one by one. If I remove this one, obviously that's too much. And okay, first I have these, which is not bad, but it's not based on how much the branch is being visited, so that's not really what I want. Now the count value is I count, and the clump it by 1 to I max count multiply by, or this max count. Okay. And if I multiply C by count, you have a bit huge value, but divided by the max count later. Okay, now you start to see a little bit better result. Okay. I guess this is the way I want it to have. Now, I think I'm missing something here. I guess I wanted to divide this, multiply by, yeah, maybe this is where I can control max multiplier. If it's equal to 1, and if it's equal to close to 0, oops. Okay, so yep, or maybe I can lerp between the max count and the sample itself, the curve view itself. That might also make sense. Huh. Okay. So maybe I can make it as C1. C2 is divided by the max count. The final curve value is lerp between C1 and C2 using some threshold value. This might make more sense. Okay, and maybe not. Maybe not. No, forget about it. Forget about it. I'm just gonna multiply these two. Yep. This is what I want. So I only need these multiple t. Now multiplier to control the thickness diversity. Okay, well, so now that I have these parameters, and let's forget about this t value, and this ramp also works. I did it, not using anywhere. Maybe I can also have this ramp parameter to control some gradual changes from thick to thin. Yep. Then finally we can control the base thickness here. So let's give several parameters here. So one is the piece scale piece scale thickness. How do I name this? Clump based value or thickness. Yeah, maybe clump is fine. It's not really straightforward, but anyway. And we have P scale ramp. And finally we have base P scale or base thickness. Let's give it from 0 to 1. Stop by 0.01 and copy this parameter, paste it here. Okay. Right. And if you want to make the whole thickness a little bit thicker, then we could control here, like make it smaller, I think, and make the not here make this P scale thickness clamp to be smaller, like 0.03 or so, 2, and this one to be thinner. Yep. Starting to look like it. Okay, so let's say this is the final result we want to get. We can also control the thickness between the branches by controlling these curve. So it's really up to you. It's based on the visiting count and the lengths and the curve view. Okay, so finally I have the final look, so it's time we can create the animation. Okay, let's make this a little bit brighter. Let's make this 10, 10, 10. Okay. So, in order to make an animation, just going to create the animation for each curve before or after setting the P scale. Either way is fine. Maybe after is fine. No, actually I need to recalculate the P scale based on the curve length, so I need to calculate the P scale after being animated. So I have to make an animation before calculating the P scale actually. Yep. So let's do that. Okay, so let me organize this a little bit, testing out a lot. So So this is where I have been calculating p-scale. So maybe I could do it right after doing the smoothness. Actually not. Yeah, I should do this here. So everything is related to p-scale here. Right. Now I could either do the animation here or somewhere in between, maybe right after the smooth. So let me check if I can move the p-scale calculation right after the smoothness. Probably I could do that. Yeah, the result is the same, so it's fine. So maybe I can split these into two sections. So this is where I calculate the p-scale. This is basic info. Now in between this basic info and p-scale, I could create the animation for the curve. So the animation that I want to create is to have a curve growth going from the starting point to the goal point, and I also make the text to show from left to right, so using some frames to show up I, and next using some frame to show X, J, W, and semicolon, frame by frame. Okay, so let's do that. So in order to do the calculation, I'm just going to use something similar to by using carve node. So the carve node will enable you to trim the curve like these. So I want to create a curve animation, the growth animation, something like these, but using code instead of using carve, because this has less flexibility. You cannot control the growth curve by curve with these. In order to do that, you need to use for each loop together with carve, and that takes too much calculation time. So instead, I'm going to use primitive wrangle together with some function to trim the curve. Yep, primitive wrangle. And the current function that I'm going to use is included inside the groom.h, which has been shifted with Houdini installation, so anyone can use it without any external installation. And inside this header file, you can access to a function called add just prim lengths, which is being used to trim the hair, but you can also use to control the curve lengths or trim the curve. So the first input is which input to trim, so it always has to be 0. And the second input is which primitive to trim, so you can use the current primitive number. And the third input is the current primitive length, so you can calculate that by measuring the perimeter. Then finally the length to the final length for the current curve to be. So if you multiply perimeter, multiply by 5, the length of the curve will be half the size of original one, like that. If it's 0.1, you get 10%. If it's 1, then you get 100%, and so on. So you need to control this value to be related to the timeline or frame value. In this case, this value here. So from 1 to 240 or any end frame, you want to convert that value to be this value to show up the text one by one. All right. So let's think. So in order to do that, you need to have several informations. One is you want to show text by text by left to right order, and that order is defined by the value text index. So if the text index is equal to 0, then that's the first letter. Text index is equal to 1, that's the second letter, and so on. So based on this value, you can define which text to show first. All right. Now, so we can use that value to create the animation, I think. Right. So let's do that. Oops. Think about it, and we need and in order to use this timeline to show all the text in one batch or one playtime, you need to know how many text are there in this setup. So let's calculate how many text are there in this setup. You can do that by promoting the text index. The maximum number of text index is actually related to the number of text. So if you look at the point attribute, there's a text index. So from point to detail, promote the maximum value as max text index, okay, which will give you 4. So it also includes 0 as one text, so 4 plus 1 is the actual number of text, so 5. 1, 2, 3, 4, 5. Okay. So now you know that now you have know that you have 5 letters. It's time you divide the frames with these 5 and letters and control this value. So let's start by creating a simple letter by letter, showing I first, then X, then J, and W, and so on. So in order to do that, first to get the end frame, the maximum frame, which is the frame end value here, then subtract by F start, which is this value equal to 1. This will give you the range of frames you have. Now divide it by number of text, in this case number of letters is equal to detail text max text index plus 1 divided by number of letters, and so now you have divided frames, and you can use this frame to control the length of each primitive. So now you could remap the frame to calculate the length value by fit frame value, which is in between f start to f end, and you want to remap this into 0 to 1 based on this frame number. So in order to do that, you need to know the current primitive text index number, which I'm not sure if I have it on primitive. Do I have it? No. So in order to do that, I need to promote the point attribute such as text index to a primitive so that I can use it on the primitive side. So I have another promote promote the text index from text from point to primitive. Don't delete it. Use the same name. Okay, now I could use the text index and multiply by frame and I text index plus 1 multiply by frame. Okay, now this should give you 0 to 1 value for each text based on the step, the time step. Probably. Let's check. Okay. And this will give you 0 to 1 value, so I'm gonna replace this. Oops. Now I have some problem here. Let's see what's wrong here. What do I get as L? Okay, actually this wasn't in between 0 to 1. Now I realized. Actually I have to do it something like this. Then make it from 0 to 1. Yeah. Okay, let's see. So if I play it, starting from I, X, J, W, and semicolon. Okay, so seems to work. Now this might be okay, but what if I want to start animating X somewhere where I is still animating? Like if I want to start animating X at this point, then I need to modify the starting frame a little bit. In that case, I need to modify somewhere around here, right here. Okay, so what I could do, let's see, what's the best way? Let me take a drink. Okay, let me check the comments. I'm looking for tutorial path growth branch with leaves. Well, in this tutorial I'm not creating leaves, but it's not that hard, I guess. I mean, you just need to pick some points on the branch where the where you can use it as a point for the leaves. Maybe I could just make a brief setup for that. Just as a random thought, the letters merging together into a thicker patch, but the letters still standing out because they are thicker, darker roots. Just getting you an idea for end of live stream. The letters merging together into thicker patch, but the letters still standing out because they are thicker, darker roots. I see. That might also be interesting. Okay. Make it thin to thick. Okay, well, where was I? So, in order to control the timing of the frames or the animation, you need to somehow edit these parts a little bit. So which one should I control? In order to do that, I need to have some margins between the end and the start. In this case, these value has to be shifted a little bit for each letters, for each frames. Now, maybe I could give a subtraction here. Here by, I don't know, 30 or something. Oh, let's try with 30 for now. See what happens. If I play it, now you can start seeing that all the text being starting taking longer time to complete, especially for the last one. So if you want to have the same time to finish the growth, then you also need to subtract 30 here. Well, which didn't really change, it just finished everything in quick, so maybe I don't really need here. What I don't like is that it's taking a lot of time. I mean, taking 50 frames. For this one, for semicolon, it's going from 73 frames to the end of the frame, so it's taking longer and longer, and that's not good, is it? No, it's not. So probably I shouldn't multiply this by text index, but doing it like this. But the problem with this is that if this is equal to 0, then there's a problem. Yeah. Right. What happened with these? Yeah, so you already are starting. So you want to shift the frame by 30. Now this seems to work. Okay. Yeah, this might work. Okay, so shift frame, offset frame, or frame ratio, I guess. Could be used to shift the frame by multiplying fn by ratio. Subtract it here. and has to be float. Okay, so if it's 0, everything starts 1 by 1. If it's more than 0, it's gonna have tons of shift. Cool. Yeah, seems to work well. Alright. Okay, like it. Now the animation is mostly done. I'm gonna wrap it, and there you go. And create the animation, something like that. Alright. Since this is all procedural, you could increase the number of points anytime you want, get the result instantly. And it looks pretty nice, eh? No, not bad. Okay. So, maybe I could try several additional stuff after this, since I am almost done with the initial setup that I wanted to show. Let me just organize the parameter a little bit, see if I can move some parameters here. So this is where I was creating a network, show this past network. Yeah, till here. This is where I was creating a bunch of points and text information, so let's call this setup. Okay, and the animation related parameter is this offset, animation offset. So, and you can control the speed by changing the end frame. I mean, by making the end frame smaller, you can make the animation faster. So it's good. Okay, now copy the animation related value here. Animation frame shift. The name is always, I'm always really bad at naming the parameters, but oh well. That's that. Okay. 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 So let me check the comments then. John Doe, my idea might require question points that don't exist. Maybe a solid frame around the letters that starts branching out from points inside its frame. The letters merging together into a thicker patch, but the letter is still standing out because they are thicker, darker roots. My idea might require points that exist. Is there a way to also create separation via scale attribute? creation points that exist. Maybe is there a way to also create separation via a scale attribute? Just joined and look at likes. You may have already done that. Not sure what you mean by separation, but each point has its own p scale controlling the thickness, if that's what you mean. Sure. Okay, well, in order to make it thicker and thicker for the text, might need to change the setup a little bit, since might need to change the animation setup, probably when to start, which edges to start animating first, so on. So in those cases, let's see, I might also need to change the weight value where I'm doing it right here. So currently, if I change the weight based on the edge distance, looks like these, more like rows like network, which might also be, looks a bit itchy but nice. And this is more based on the flow of the text network. Now in order to make these things to stand out from thinner value to thicker value, I might need to change how the network being created. First of all, let's see. Closest point based on importance, probably, yeah. I think that's the way to go for sure. Right. I need to create a nice weight value based on this, the surface distance and the closest distance here. I think by combining these two nicely, might be able to create a network that I'm looking for, probably, or not sure. Maybe. Maybe. Let me think. How can add leaves proxy plan by assigning alpha texture? How can add leaf proxy plan by assign alpha texture? If you're just looking for a position to place leaves on some of the branching points, then probably you could do that during the animation, or right at, maybe before the animation. Let's see. Well, I'm just gonna do it randomly, okay? Since I haven't tested out. Let's say you have primitive wrangle. You pick random points. How should I do that? What's the best way? I just need to pick several points from here to use it as a leaf candidate. So just gonna pick random points from here. Int pts prim points. And if random I plus primitive number plus maybe I can just use at p is less than, I don't know, 1% or 2%. Maybe I can control this. Then use that point as leaf point. Okay, let's check. So do we have a leaf point? I don't see it. That is because, okay, so let's say these are the leaf points. So I do have several points here and there. Okay, now I could create a random angle, a random direction. Now in order to do that, I could have another resample to calculate, or maybe orient along curve to calculate the tangent vector and use that as an information. Which one is the tangent vector? What was the other one? The y-axis. Okay, tangent is normal. Okay, so I can use the normal. Now, at this point, I could get the tangent vector, which is normal, and then get the perpendicular vector for this tangent vector, which is this up. So let's get that as well. Up is 0.0 up. And what I want to do is to rotate this tangent vector a little bit with this up vector. So rotate the matrix by, I don't know, radians of 30 degrees or something, and then using up vector as an axis, then rotate the tangent vector by matrix, then use that to create a leaf line. Okay, or I don't know, new leaf point or new normal. I don't want to make it as a normal, but because it's gonna affect the pipe and so on. So set point attrib, I'm gonna make it as a direction vector attribute to this leaf point. Like this. Okay, and then we can split, or we can just pick the leaf point remove the primitive, only keep the points. In order to remove the primitive, I need to have another delete node, primitive, delete everything. Yep. So these should be the leaf points. Maybe too many. There's too many points, so let's limit the number a little bit more. Okay, I see there seems to be a lot of leaf points for some curve. That is because of this random value, I guess. So let's change this. Still might not be a good idea. Instead of using primitive wrangle, I could use point wrangle, I guess. And then using point wrangle instead. Okay. And write it something like this, and tangent pt none. Actually, you could just get like that, like that, and you can say like this. And where is, what did I do wrong? Syntax error, unexpecting. Okay, missing semicolon here. What else? Reference to undefined variable I5. Okay. Okay, I don't have I anymore, so let's delete that. Okay, now doesn't really look different. Why do I have tons of points here? Maybe the sample rate is different with these positions. Might have tons of points here. That might be is the reason. Okay. In those cases, I should do it before using smooths. This is what I should do. And I should use fuse. Yeah, and then, well, maybe not. Yeah. Maybe I should do it something like that. That should reduce the number of points. Yep. Somehow. Well, now, okay. So now that I have a number of points, which I don't which I can use to place the leaf. Let's have like, I don't know, plane to place it as a guide for leaf. Okay, and let's see how it goes. So, and the next thing I should do is, after I have picked up the leaf point, I need to set up the up vector and the normal vector value. So for leaf points, so the normal vector is I don't know, direction. Then the up vector is, maybe I can just use the current up vector as it is. Okay, now let's see what happens. Copy 2 points. I think I need to also set the scale, and probably also need to animate this based on this animation. But let's see what happens. Okay, it's too big. P scale. And let's compare with the curve, how it's being placed. Okay, so actually want to place this a little bit off the center. Yup. Okay, looks a bit more like it, and want to make it thinner on the X. Okay, doesn't really look like a leaf, but if you place a leaf instead of this grid, might look more like it. Maybe I could try with the circle instead, just to make it a little bit closer to how it should look like. Radius 0.2, 1, center 0.25 or 0.5. Okay, something like that. Okay. And if you control the amount of leaves, starting to look like it. If you combine with the final result, and you might wanna control this size of the leaves based on the thickness of the branches as well. Maybe, I'm not sure. But anyway, now that you have it, it's time you could connect this with the animation, probably. So this is how it's being animated, and based on this animation, the amount of leaves, the way the leaves being created also has to be controlled. So can I just place this here? I don't know. Nope. So that was not okay, because I'm using the randomness here to control how much which point to use as a random, which point to use as a position, I mean the leaf position. Maybe if I remove this one, might be okay. Just using the point position. That might be okay. Nope, still not. Yeah, probably that the point position, the point number, I mean the end point is being changing based on the trim, so this itself doesn't really work. So you need to get the corresponding point leaf points after you have created the animation. Okay, so, and probably you could also copy the, I don't know, the scales and stuff like that as well. And probably if you want to also pick up the scale, then you could pick from somewhere around here before doing the polywire. Alright, so let's try doing that. Going to use the point wrangle. Before copying the leaves, you could check these points referring to the animated leaves, I mean animated branches. Check the distance, and if distance is close enough, that means the point is touching the branch, the leaf is touching the branch, means you could have that point alive, else you could delete it. So if the distance is far, then you could remove the point. There you go, and let's check. Let's check with animating the curve. Okay, so far that looks good, but you also want to scale the leaves because it's just popping up, doesn't really look natural, right? So next, copy the p scale value. Okay, so to do that, you need to access the p scale attribute from the primitive. To do that, you could use the prim and uv, just like I'm doing in everywhere. Get the p scale using prim uv from second input, p scale. Okay, now I could control the current p scale of the leaf multiplied by the branch p scale. See what happens. Okay, well, it's a bit jiggling a little bit, so and because the branch p scale is a bit too small on the edge, I'm having a bit too small branch here, so might not be a good idea to just use the branch p scale after all. Okay, so might need other value to control that. Well, I could either use animation value or based on the curve view value how much it's been alived. Yeah, that might be a value that I could use probably. So Let's see. We could probably can calculate how much the branch point has been alive by using some frame-based value here. So based on those frame-based value, we could kind of specify the life of the branch. Okay, how much has been lived. So let's see what could be that value. So this 0 to 1 is indicating the life, right? I mean, if it's equal to 1, then that's been grown to the end. And and oh well. It's a bit hard. It's a bit hard. If I'm using solver, then that'll be easy because I can just recursively add that value. But since this is just a procedural one-time calculation, and so I don't have any like stuck information here, so I need to kind of estimate the value from somewhere. Right, let me think. So P scale was not doing a good job, not too much. So what else I could use? What else do I have? I have a count, I have curve view. Curve view is not a good value to use as well because it's always from 0 to 1. But maybe I could also use these. If I just use solver, then that'll be just easy. Yeah. If not, how? I don't know. Yeah, maybe using the frame as well as the curve view value is the key, I guess. Let's see. Point wrangle. Okay, and so just need to figure out the right value for this B scale. Okay. Maybe I can have some kind of value onto these curve while I am doing the animation, while making the animation. Right. So this is trimming the curve, right? And as the result of the trim, I could remap the current curve U to some gradient value. Right. And to do that, maybe I could create another value called EL by using, instead of fit, I could use a eFit, which is a unclamped version of an fit, which could go more than one in this case. that could be used as some kind of information. Let's check. If I look at the EL primitive, so you could also have negative value. Okay. Yeah, so it could go more than one. If it goes more than one, then that means the growth has been completed. Right. And you can relate this together with the curve view. Right. So in order to do that, you need to have a curve view value as well. Do I have it? Nope. Let's create that. Resample. Curve view. Don't add any points. Okay. Now and I could have another point attribute, point wrangle here. Okay, and maybe outside, or I don't know. Get the, first of all, EL from the primitive attribute, so point prims prim EL primitive. Okay, that's the unclumped version of the timeline based value. And let's make the maximum to 0 so that I don't get negative value. Okay, and let's also get the curve view. Okay, now based on this value and the EL, I would like to create some kind of a gradient value, right? Okay, so how should we do that? So I'm gonna create a fit function, and the curve view is in between wait, let me draw some curve sketch. So okay, and then this is curve view, and this is being animated, and when the timeline is equal to 0.6, where it's somewhere in here, the leaf size should be 0, and gradually increasing the leaf value. And probably if you have enough shift, you have scale equal to 1, but then at some point the scale becomes smaller and smaller, and if the curve u and t is equal, then the scale is equal to 0. So based on this value and this current value, I could remap the curve view, let's say CU, which is in between, if it's between the t minus, I don't know, like some kind of an offset like 0.22 t, then it should be remapped to 1 to 0. Something like that. Would it make sense? I don't know. Maybe. Yeah. Let's try. Shall we? And let's simulate this. So if it's 0.8 and if t is equal to 0.6, then there'll be 0.4, 0.6, and since 0.8 is more than 0.6, so it becomes 0. So if it's less than 0.4, then it'll become 1. So maybe that might make sense. Let's see. Alright, so where was I? So fit the curve view, and EL is the t in this case, and minus some offset like 0.2 EL 1 to 0, and make it as B scale, and I should bring it here. And oops. Actually, maybe I should just refer to the curve view here. Do I have it? Yeah, I have the curve view here, so actually I can just calculate the things that I was trying here. I just need this EL value, which do I have it here? Nope. Primitive. Oh yeah, I do have on a primitive side, so I can get that. So B scale is equal to, and I also need the curve U, so float curve U is equal to prim UV curve U prim UV. Fit curve U and EL minus 0.2 EL 1.0 0. Okay, and seems like I'm getting really large number here for some reason. Let's see why. Well, probably need to scale the P scale with some final thickness, final size. Because if it's in between 0 to 1, then that might be too big. If it's equal to 1, yeah, obviously that's too big, so I have to finalize the size by the uniform scale. Which could be 0.01 or something, or 1. Still big. Okay, let's check. Okay, somewhat I'm getting a decent one, but sometimes I'm getting a jiggle. Somewhere around here. The leaf is going back and forth in terms of the size for some reason. Yeah, but overall it looks okay. Yeah. So if I could just fix those like wobble here, maybe things could be better. Now why am I having these, and seems like point is also moving. Interesting. I might need to restrict the distance where the point is being made a little bit more. Maybe that's not the only case. What else? It's interesting to see that the point is, but I can see that the point is shifting here. That's making the points to move. Interesting. And those shift happens when it's been animated for sure. So I want to make sure that the leaf points only used when the exact point is being used. It's being picked. Now I thought I was doing it here, but instead of using a XYZ distance, maybe I can use a near point. Okay. Then calculate the end distance. This will make sure that the point is on the exact position. Alright, how's this? Okay, that fixed it, I think. Maybe not. Maybe not. Interesting. What's this? Is this because the curve view is changing a lot? Maybe that's one of the reasons I could think of. Let's see. Gonna visualize the curve view attribute, see if it's changing. If that's the reason, then what should I do? Or maybe there are multiple number of curve view exist here because points are being, there are multiple number of points here. Yeah, that just as I assumed. Okay, now that's okay. So it's picking up random curve view value. So that's the problem. I see. Well, what to do that. In those cases, maybe I could give this leaf point which branch it belongs to. Yeah, and only search for the related branch. That makes sense. Okay, so curve view. Let's check. Oops, no. Let's check the primitive attribute for this curve. If there's any information I could use, nothing. Oh. Oh. Nothing. Okay, let me also check the number of primitives. Okay, so maybe I could just pass the primitive number, because the number of primitives doesn't really change even with the animation. You have 2499 here, so the number doesn't really change. So you could pass this primitive number to each leaf point. Okay, so let's do that. So get the primitive number. Then pass that information to the leaf point. Or just say primnum, prnum. Okay. Now, having this information, I can filter which leaf belongs to which branch. Going back to here, where I'm looking for a curve view, I could, instead of using XYZ distance, I could specify the primitive number. Actually, but I do still need the UV. Yeah. So when I calculate the XYZ distance, I could specify the group. One I2A prnum, and then p scale, at p prim uv. Yep. That will do the job. And I could make this alive. So this primitive should be equal to this primitive number here. And because of that, I should not have any wobble anymore. Let's check. Okay. Finger crossed and see what happens. There you go. Nice. Alright. Okay. That should do it. Alright. Now, I'm not sure if this solves your problem, but this is one of the way. I guess you could place leaves in between branches. Okay. You might need to, I don't know, use like leaf textures to make it a bit prettier, or leaf shape to make it prettier, but for now hope you could imagine how it looks. Well, I'm not sure if this is good enough, but I'll just leave it as it is and you can tweak it to your need. So I have a bunch of parameters: scale for the leaves, number of leaves, and so on. Maybe less number is better. Alright. Okay. Well, let me organize this a little bit. And let's also try to see if I can make the text thicken by starting from the core to wrap it up. Okay. So these are the leaves. I don't know. I don't know if I really want it to, but I'll just make a switch if I want to include it or not. And the number of leaves is set here, or this is the ratio, leaves ratio. And then you have a scale, and then you have, well, this was the scale. What was that? Why do I have two scales here? Okay, so this was unnecessary. This was not net. Wait a minute. Well, so I already have P scale here, so maybe I can remove this one. Yeah, makes sense. Okay, what else? I have these offset here, the animation offset for the leaf. So leaf anim offset, which has to be in between 0 to 1, because this is based on the curve view value. So okay, what else? I think I also have an angle, this one, for the leaves. So if I make it 90 degrees, then it will go perpendicular to the branch. It's up to you. If it's 0, then it's along the tangent vector, which is also unnatural, so maybe 30 is okay. Then let's pass that value as well. Right. Okay, so that's it for the leaf, I think. And finally, I might want to disable the leaf, so in those cases I could use switch to whether include this in the final or not. So I can copy this toggle has leaf to this switch. If you don't need it, you can turn this off. If you want it, you can turn this on. Yep. Alright, now let's check how I can make different types of animation. Now that might be hard, so I'm not sure if I can do it. But let me think at least. Okay, so first I have a network like these, and well, first thing I could think of is to just use the same network like I have here, but change the timing for each branch to grow. Pick the branch which is close to the core curve, which is this one, and then animate the path which is far from this core later. That's one of the that's one thing I could think of. Another one, I could introduce another weight here. Let's see. So I already have a surface distance here, and been using the closest distance and the edge distance. Now I was using lerp, but instead of using lerp, maybe I think there might be other way to create the network. Right. So, for example, if it's starting from somewhere around here, which is a bit far from the core, maybe I want to keep the distance, the network that runs through these points. I want to keep the distance between these core curve for the shortest path that I'm creating. Now how do I actually do that? How do I actually do that? Okay, so to do that, let me create other type of weight here. To here. And similar to this one, I'm calculating the closest distance. Just gonna copy it here. Now the weight based on this closest distance could be exaggerated by using power function by, I don't know, 4. See what happens. And if I look at the network, created network, do I see any difference? Let's let's make it 10, 100. Okay, so it's not changing anymore if it's equal to 1. Okay, so if it's equal to 10, then I think it's trying to keep the distance between the core line and the current point. So I think that makes the curve going really straight or parallel to the core line. Hope. Let's check the final result. Animated result. Gonna skip the pipe for now. More, not sure, but not so bad, I guess. And based on this network, I could start animating the center, the one close to the center first, then animate the one that's far from the center later. Okay. So that to do that, I need to go back to where I'm creating animation here, and need to know which one has the higher weight, which one has the lower weight, and that can be retrieved from this find shortest path and output the cost attribute. This one. This should show how much it costs to go over. Let's try to visualize this to see how it looks like. Overall, I need to compare between the primitive, not between the points, so maybe that this is not the attribute that I want to use. Yeah, maybe not. This is just showing the starting to the end. So instead of this path cost, is this okay? So the primitive based value, let's see, let's colorize this and see what it looks like. Doesn't really show the weighted value as I want it. Well, at least the one that looks similar. No, not really. Not so much. Okay, going back to the weight value. What if I change this to 0.1? Or 10? Maybe this isn't working that much. What it actually is a path cost? Well, that's also my question. What is it? It says if a given a primitive attribute with a specified name will be created indicating the cost of each output path. If keep original geometry is enabled, this path. So probably this is like how fast it reaches to the goal. I think. Okay. So. Well. Let me pick up one primitive from here and see how it looks like. And looks like these. And the core, it looks like these. I need to pick another one to compare. Okay, let's pick this one. So I have two of these. This is the center core. So what I want to do is to get, like, estimate which line is closer to the core. From what I'm looking at, maybe the left one is closer to the X. It's not so obvious. Not so obvious though. Wow, so it's a bit, maybe this method is not as good as I hoped. So let's think about the other way. Oh. Well. The weight has been calculated like these. And if I visualize the weight, how does it look like? What's the maximum? Okay, it's really small. Maybe I need to normalize this a bit. So let's get the maximum for the weight. Normalize it. By dividing by the maximum weight. Did it normalized? So detail max, max weight. Max weight, and the result is should be in between 0 to 1. Yup. Okay, now maybe the power function is a bit too big. If it's equal to 1, okay, so you get these gradient, which is still okay. 2 might be still okay. 4 starting to have a bit distance between the small and larger one, so maybe go with 2. See what happens. All right. Well, the weight also take care. I mean, you also need to care about the shortest distance as well. Shortest distance also being used along with the weight for sure. So, well, what if I omit distance from cost? Now you have some interesting result, but not really what I want. What if I check this omit distance from cost and increase the closest distance? Okay, now I don't see any changes anymore. Interesting. If enabled, the length of an edge will not be included in the cost of the edge. This can be useful if edge cost that is not directly dependent on the length that's desired, which can be specified a custom edge cost parameter. Yeah, probably I don't really want this cost value. So although if that's the case, yeah, the way I have added the weight doesn't really make any sense. So right. I think maybe the shortest path is not the way to go for this type of things that I'm trying to do. Where was I? So I have edge way. But omit the distance cost is, I think, is a good attribute to have the final result. Yep. Bit too thick. Okay. Well, maybe as John Doe was saying previously, maybe I should gradually increase the number of points so that you can expand the network frame by frame. So in those cases, maybe disable these, and maybe I can group those points based on the distance from the core. And based on those different groups, I could make a custom path. So I could do that. I could make an additional point wrangle here. Do the similar distance calculation here. apply that closest distance to an attribute, then calculate the maximum distance per class, I guess. So per class, I want to calculate the closest distance, maximum, change it to max closest distance. Let's check point max closest distance. Okay, there you go. So this will be the maximum. So if it's close to 0, then that means it's touching the core curve. If it's equal to 0.11 and so on, then that's the farthest point. Now I could divide the point based on the distance by, I don't know, that's going to be kind of a discrete network, so it might not look good, but let's see. In order to make it a bit more smoother separation or groups, I'm gonna make it as a float for now, and a closeness is equal to closest distance divided by the max closest distance. So if it's equal to 0, then maybe I should name it far. If it's equal to 0, then that's the most close value, and if it's equal to 1, that's the most far value. Far. Then let's check the value. So you get in between 0 to 1 as a value. Okay, now based on this value, I want to recreate the network where I was using here. Okay, right. Now let me see. The weight means if you have more weight, given specified point attribute on a surface geometry will be added to the cost of path giving business. So weight is more like an additional distance, right? So if you have high weight, it takes more time to reach it to the point. Is that the case? And if you have a small weight, you have high chance to visit there, isn't it? Or is the opposite? The cost of past visiting each node. The way I was calculating the weight here, edge distance, right. So I could have at this point I could create a network, which I was doing here. Probably I could insert this here. Doesn't affect anything at this moment. And when we are creating the network, let me test out. Based on the far value, maybe I could separate the network. Okay, so I could give conditions here, if and the n far so the current far divided by 0.1 floor is, wait a minute, floor f far, no, n far divided by 0.1 . Am I missing something here? What am I missing here? Ambiguous call to binary operators, candidates, integer, float, flow. Ah. Okay. Int a I far is like this. Int n far is like that. Okay, this will give you kind of a discrete network, but doesn't really look good, does it? If I make it 0.2, nah. I make it 0.3. Nope. Nope. Actually, I should write it like this. Okay, this is making like 3 layers of like that. One in the center, one on the middle, one on the corner. And if I make this 1, you have 10 layers. That might be too small. Yeah, maybe at least you have something like this. So this will give you at least 4 layers. And based on that network, you have some, oh, and The problem is some of the network is not touching with the starting point, so you're only getting the center one. So that is a problem. So you need to create another value here. If one of the point is start, then you can ignore this one. So okay, so or start is equal to 1 or and start is equal to 1. Now I'm not getting anything here. Oh, the network is not being created anymore. Wait a minute. I should do something like this. Okay. And wait. Oh. Actually, this is not correct. I should give a condition something like this. So this is one condition. This is another condition. Didn't really work. Well. Let me see. So so I have a start group. So this is one of the condition. I could create a point, but what if I do it like this? Okay, so it does create, but it doesn't really bridge the other layers, so it doesn't really mean anything. Alright, makes sense. So the way I wrote is actually doesn't make any sense at all. Okay, forget it. It's harder than I thought. Or I'm just not thinking straight. If I could just use way to guide where the path should go, then that'll be easy, but I mean, this itself is already going straight from what I see, so maybe I can just get those polyline or curves and I don't know, based on distance, from each path to the center core. I can just change the timing when it's being run or not. Okay, so in those cases, for each primitive, I could calculate, I can estimate how far is it from the center core. Right, so to do that, I could use a primitive or point wrangle for each path. Maybe I could do it here or after the fuse. For each point, no, maybe before fuse. For each point, check the distance between the core and let's just forget about these. It's not using and what was I? So closest distance, and then what was I trying to do? Okay. Okay, so and I want to calculate the maximum value. From point to point based on the class, just like I did previously. So that I can normalize the value. Actually, I could get the average and promote it to primitive. If that works. No, didn't. Okay, that is because I don't have a class attribute on the primitive. So first, let's promote the class to primitive. Then promote the point to a primitive. Get the average. All right. Wait a minute. Actually, maybe I shouldn't use the piece attribute after all. But I just want to calculate the closest distance per primitive. So that's just going to work. Okay. Now in those cases, I could have, finally, I could have the max closest distance from primitive to detail. Okay. And then use that to normalize the value. So normalized closest value is closest distance divided by detail. Okay, then check the primitive attribute closest distance. Do I have a point color here? Nope. Okay, so oh, the value that I wanted to visualize was NC, actually. NC. Okay. So this if the color is close to blue, then that is close to the center core. If it's close to red, it's close to the outside. So so probably it's close to what I was looking for. So first I want to show those blue ones, then gradually showing the red ones later. Right. Right, so to do that I need to change the animation code a little bit based on this information here. Right, and I think I can just connect this here. So NC is the additional attribute that I've created. Okay. And that value has to be preserved till the animation. If let's check. Okay, so I do have these NC, which is from 0 to 1. So now I can use these to change the attribute now. But before going to the set, actually maybe I can recalculate the maximum per primitive based on the class. Yeah, that might be better. And then use the maximum attribute. There you go. That should give more differences between each primitive. Yeah, that should do it. And going back to the animation, I am going to copy this, create additional animation stuff here. Now where should I control? So right now every line starts at the same speed, and that's what I want to control. Based on the NC value, I want to control the speed, how fast and which branch grow fast and which ones comes later. Right, so and for that purpose, currently everything is, this L has to be change based on the NC attribute, and in order to shift the value you can control this shift value. So you can use NC to control this shift somehow. So if the NC is equal to 0, that means it's close to the center. If it's equal to 1, that's far from the center, meaning those red colors. So the shift means if shift is bigger, what was it? What was that? If the shift is bigger, the animation starts slower. If it's equal to 0, it starts faster. So more shift you have, slower it gets. So probably you could just multiply this NC with some shift and see what happens. Not much change I see. Why? Because I'm not using this one. Okay. Okay, so let's replace this network. Here and see if I see any changes. So hopefully the blue ones grows faster here. Is it? Let's change this. See the difference? No, I don't see any difference. Ah. Okay, so something must be wrong. Am I getting the NC value? Yeah, do I am. Yeah. Okay. And if I wait, maybe I should multiply it here. Oh, I do see some changes. So this one is without NC. Growing, everything is growing on the same speed. This one is growing based on the NC, so hopefully the blue one's growing faster, the red one growing later. Not so obvious. Let's use the power function to exaggerate the value. So, well, at least I do see the bluish color comes fast and the reddish color comes later. But these are not so much. I mean, doesn't really give you a feeling that it's growing from the center. Maybe the calculation itself in order to estimate how far it's from the center itself is wrong, or from the network itself. Yay. Oh well. But at least in terms of the calculation, multiplying by NC seems to work, so I think that's fine. It's just that I still need to think about creating the network a bit more diverse based on the center distance to the center. Well, but at least this is kind of a use for in some case, so I'll just leave it here. This is the old version. Let's leave it as V1, V2. This is not used. Okay, so well, it's already taking a lot of time, so maybe I should just quit at some point. I'll just leave it up to you how you create these network, but based on those NC value that I've created here, I think it's possible to start growing from the center to outside curve. Just need to create the curve itself a bit more smarter way instead of using maybe a find shortest path. So that's that. Hopefully you get something out of this. Well, I think it's a good time to finish since it's already 5 AM in the morning in Japan, so getting sleepy. I think I really need to go to sleep, so I think I'm gonna just finish this live. Now, as always, I'm going to upload the file and paste the link to the description page of this YouTube so that you can go to the link to download the file. The video is also being archived so you can watch anytime you want. So hopefully you like the live stream. And let's finalize this by making Vex, or I think it could also even, okay, now I'm missing a little bit, some parts here. Maybe that's because of the final NC value that I have added. The shift was not enough here. Yeah. If I make it to 1, I think... Oops. Okay, well, I think I'm missing... Let me just fix this one so that in the end frame I could have all the value. Now, to fix this, probably I need to do the shift here as well. I'm not sure. Yeah. Yeah, I think that was it. Okay. So one thing I wanted to try here was to use more complex characters like Japanese characters or kanjis or Chinese or things like that. Because these characters have tons of primitives that might gonna break the system, so just want to check if it's gonna work. So let's make the font to 2-byte font to test. I'm gonna use a Japanese font since I'm Japanese. Which one can I use? Hiragi no Mincho. Alright, then where's the text? Okay, now I already found some errors here. I can see that the normal direction is different here and here compared to the one that I was using previously. So I need to make sure that the normal is always facing front side. Okay, so in whether, so based on the font, sometimes the normal has been flipped. So I need to make sure it's always facing front side too. So I'm gonna make a norm, gonna calculate the normal primitive and check if it's facing front or not. If it's facing backward, then make a reverse group. Okay. Okay, now let's check if I change the font to Lato bold, still works. Get the final result. If I change the font back to Hiragino Mincho, okay, still get the result. Somehow I'm not getting the middle bar here. Why is that? Let's check. So I do have a curve here. Do I have a, oh, now I don't have a network here somehow. Huh, I'm missing those network points here. That is because I don't have enough points. That is because somehow the points not being created much inside. Now the volume is not enough somehow. Maybe I should increase this volume sample divs based on the bounding box size of this geometry. Let's see, how much is, what's the size of this bounding box? We can estimate the width by using bbox op input and use the x size. So the x size, that will give you value 2, so maybe I can multiply it by 100. Okay, that should do it. Alright, then let's check the final. Alright, nice. And what I wanted to try is to use the kanji, like really complex kanji characters, like such as something like this. Oop, couldn't. This is bara, meaning rose in English. Okay, And in this case, I might need tons of points in order to create the network. And more volume, I guess. Yeah, I'm missing some volumes here. Okay. Maybe I could make it like 200 multiplied by 200. Okay, well, that was too heavy. Maybe 120. Okay, that should do it. So, let's get what. This is a rose. Looks like a horror movie. My name. Horikawa. Okay. Not bad. Okay. So you could use a 2 byte characters as well. I'm gonna finish with the fix. Okay, let's change this back to a, I don't know, a Georgia. Okay, one last question. What topics should I study to be good with computer graphics, mathematics, and physics wise? Which branch of coding? Well, I myself is not really good at computer graphics, so I'm not sure if I'm the right person to give an advice, but at least for me, I did like mathematics, but wasn't that good. But I started the coding. I started using mathematical coding or geometrical coding stuff using a parametric design tool like Grasshopper, Rhino and Grasshopper. Learned basics of linear algebra, like vectors and matrices, and which gives me more interest on mathematics. And when I start using physical simulations, I also it also made my interest on physical simulations to a real computational physics. So I don't know, starting off with all those, I don't know, fancy tools I think is a good start. Then if you're interested enough, then you could go to the basics, like start from linear algebra or physics and so on. Well, also, can't we, instead of scattering in volume, we can scatter on geometry and add iterations point toward a direction to get a point volume? Would be not as heavy as volume, right? Yeah, might be. Yeah, I think that's also a way to do it. Make topic Japanese roof tiles. Like Kawara roof. Sure, it's not that hard to make, I think. I mean, but the way the Kawara is being made in Japan is all different based on the area, the regions. For example, if you look the ones in Okinawa, or if you look at the ones in like Tohoku, you get totally different types of roofs. So that might be interesting procedurally. Okay, well, that's it for today. Hopefully I'm gonna do the live stream next week as well at the same time, so if you could join, that would be great. Now, thanks for watching till the end. As I said, I'm gonna upload the files as soon as I finish the live stream, so please come back to the video description to download it. Okay, that's it. Thank you and good night. See you next week. Have a nice weekend.